Okay. Next, can say about infimum. Yeah, infimum of a set. Yeah, I still talk about S. Yeah, if A is a lower bound, if A is a lower bound, yeah, of S and no lower bound of S greater than yeah A, then A is a, you can say an infimum. Yeah, infimum of what? Infimum of infimum. Yeah, of F. Yeah, of S. So from this definition, we can say that an infimum of a set S is the greatest lower bound. Yeah, is the greatest lower bound of S. So to find the infimums of a set S, we can find all the lower bound. Yeah, all the lower bounds. And then choose the one that is the biggest one. Choose the best one that is the biggest one or the greatest one. You get that is what is an infimum of set S, right? Yeah. Next, what is minimum? Yeah, minimum of set. Bound, no bound of set, right? This one minimum, minimum, minimum of a set. Yeah, as manner as what? Maximum. We can say if A is a sorry, along is earned. Yeah. If A is earned infimum. Yeah, infimum is one infimum of S and A also the elements of what is also an elements of S. Then A is a maximum. Yeah, minimum, not maximum. Sorry, minimum of what? Of S. Yeah. So when you find lower bound, infimum, as well as minimum offset, they are related, right? From this, I can say that maximum offset, what is an infimum offset, and infimum offset is an upper bound. Sorry, is a lower bound offset, right? So from this, we can like find something that is necessary condition and sufficient condition. Minimum, you get it what if it is a minimum, it is an infimum, and it is a lower bound, right? If one number is a minimum of what a set, it's always an infimum of a set also, and it's always a lower bound of that set also. And in contrast, I mean vice versa, it's not always true. I mean that if we say that a number is what is a lower bound of a set, we cannot always conclude that it's an infimum and it's a maximum. By the way, if you have a minimum of a set, you always can conclude that it is a minimum. It is an infimum and it is always a lower bound. Yeah. And for the upper bound also, a number is what is the maximum of a set. We can say that that number is also supremum of a set, of that set, and it's also an upper bound of that set also. In contrast, it's not always true. I mean that not all the upper bound is always the infimum. Is the supremum, and it's not always the maximum. But the maximum is always the infimum and the upper bounds. Also, the infimum is also the upper bound, but a number is an upper bound is not always the infimum. Got it? Yeah. Also, this one, a number is an upper bound of a set. It's not always the maximum of that set, right? Some set have upper bound, but it has no supremums and maximum. Okay. Also, but in real number, we can say like this. It is the upper bound. We always get it in what? We get it as what? Supremum. But all the upper bound or the supremum are not always maximum. For the lower bound, supremums, and maximum also. Again, I can say one thing. When a set has an upper bound, we can say that it is bounded above. Okay, you understand? Yeah. When a set has a lower bound, we can say that it is bounded below. Yeah. Above means something high, above something high, and low something that is, not high, something that is lower. Yeah. So again, a set has an upper bound, then we can say that it is bounded above. A set has what? A set has a lower bound, we can say that it is what? It is bounded below. Moreover, if a set is bounded below and bounded above, then we can say that it is bounded, right? Okay. And as I told you, any subset of real number is always bounded. So it means that it is always bounded below and bounded above. And that we can conclude that any subset of real number has a supremum and minimum. Any proper subset, not only subset, because subset can be equal to real number. Any subset of real number can be equal to real number. So I can say a proper subset. any proper subset of real number is bounded, and any proper subset of real number always have what? Supremums and minimum. Yeah, but I cannot confirm that it always have what? Maximum and minimum. I cannot I cannot confirm this. I can confirm only it they have sub and in supremum and infimum. Okay. Okay, let me omit this one. Yeah. In sum up, yeah. First, I want to say that subset, I mean a set in general, I mean a general set is not always bounded. Yeah. By the way, if you can find an upper bound of it, you can find a lower bound of it, so we can say that it is bounded. If we want to say a set is bounded, it has to be bounded below and bounded above. Yeah. Vice versa, if it's in contrast, I mean like that, if a set is bounded below and now bounded above, we can say that it is bounded. Yeah, some set is bounded below, but it's not bounded above, so we cannot say it is bounded. We can say just say bounded below. Some set is bounded above, but it is not bounded below, so we just say it is bounded above. We cannot say it is bounded, right? For the word bounded, we have to have two necessary conditions, below and above. Yeah. Yeah, as I told you, if S is bounded below, yeah, below and bounded above. Then we say that S is bounded. And what is bounded below and what is above, as I told you? As I told you, S is bounded below if it has what? At least a lower bound. It means that if we can find a lower bound of S, we can say that it is bounded below. Yeah, in contrast, S is, yeah, is one bounded above. If it has, yeah, if it has at least an upper bound. Yeah. If you want to say that a set is